fairly common step at the end of a reaction workup is to evaporate solvent. Okay, so we have a reaction mixture where there's a compound of interest dissolved in organic solvent with a low boiling point. You're going to have that mixture in a round bottom flask. Okay, so before we even put it in the flask, we want to know the mass of the flask. So you can go to the balance, put a cork ring in, either this way, or whatever holds the flask best. Tear it out, put the empty flask on, and record that mass in your notebook. Then you can add the reaction mixture to that flask that you've measured the mass of. Alright, so this is organic compound dissolved in solvent. Next up, we're going to remove the solvent by rotary evaporation. Now in the organic lab, we have a couple of rotovaps, or rotary evaporation apparatuses. They're all about the same kind of thing. There's a place where you can attach a flask, and through here, this is going to be a spinning mechanism to spin the flask. Okay, so our flask with organic compound in organic solvent will start by being clipped on. Right, you want to hold on to that flask, then use this blue clip. There's a skinny part and a wide part. And here we have a skinny part and a wide part. So you match that up and put the clip on like so. I'll show you up close how that looks. Okay, skinny, wide, right over the seam of where the flask meets the adapter. Okay, then you can turn the instrument on, and this dial spins the flask. So you don't want the liquid to slosh, but you do want it to spin at a pretty good clip. Alright. Now, we are connected to this piece over here. There's cold water going through these coils, so we are essentially just going to be able to distill off the solvent, leaving behind the organic compound. This is hooked to the vacuum, which lowers the boiling point of any compound. But what it does is it lowers the boiling point of the solvent, such that the solvent boils at room temperature or just above, using a warm water bath as enough heat to get the solvent to boil with the pressure of the reduced pressure of the vacuum. Most of the organic compounds that we make have much higher boiling points, and they don't boil or evaporate at this these kinds of temperatures, room temperature or just a heating bath. Okay, so what you do next is reach around to the house vacuum connection and turn it on. You hear it. And there's a little valve here. Okay? If I turn that valve, it closes a little hole and exposes our system fully to the house vacuum. Now you can see we're actually almost boiling here, and we have a vent. So we're going to do this really gently to avoid changes in pressure. As I turn this valve 90 degrees, the boiling in that flask is pretty vigorous. So I'm just going to be gentle. It's not even fully closed here yet. And you can hear more silence. As I turn this valve 90 degrees, I have exposed the system fully to the house vacuum. There's a little bit of condensation on the outside of the flask because evaporation cools the system. Okay? Just like sweat cools your skin as it evaporates, that's what's going on here. So as some of the solvent evaporates, it cools that flask. So now that the boiling has calmed down, I'm going to lower my flask into that warm bath. That'll speed up this process of boiling away the solvent. And I'm going to just keep the stirring rate as fast as I can without sloshing. Alright, so your flask is on the vertivap, and it takes a little while for the solvent to evaporate. Okay, so you'd walk away, go do something else, and come back a few minutes later. Alright, so I'm going to try to show you that. What's going on here. So you can see boiling and spinning. Alright, and a really good question is, how do I know when it's done? So the level of the liquid in that flask should be going down, down, down. Okay, and so what you can do, if you're thinking you're close to being done, is you can bring the flask up to look at it more closely, slow the spinning rate down or even stop it, take a mental snapshot of the level of the liquid, and then get it going again, spinning in the warm bath. Leave it on a minute or two more, and check it again. Now here I clearly have a lot of solvent that needs to go be evaporated. Okay. At the end, you might have solid left in the flask, or you might have an oily residue, and you essentially want to keep rotovapping until you don't detect any more changes in the level of liquid. Now your instructor can always help you with this process. If you don't leave it on the rotary evaporator long enough, there'll be residual solvent that will inflate your yield, and it might get in the way of any chemical analysis we do for product identification. Let's check on the progress of our rotovapping. I turn the spinner way down, and I can see here I have a yellow oil residue. So what I would want to do now is, I've clearly lost a lot of solvent. I'm going to put it back on the rotovap. I'm going to turn it back up, the spinner back on, back in the warm bath. It's still under vacuum right now. Another minute or so, and then I'll check it again. And if it looks the same, then I'm done. Alright, let's take a look again. Bring it up, turn the spinner off. Let's take a look at that residue. It really looks to me that it's about the same as it was the last time we checked. And so we're going to call it done. Okay, so now to finish removing the flask from the rotovap, here's what we want to do. Turn that valve, move straight up and down. Now you can hear the vacuum is vented. And then turn the vacuum off behind the rotovap at the source. Now the vacuum is done, we can remove the blue clip and take the flask off. You'd want to wipe off the outside of the flask, then you could take the mass of the flask and subtract off the empty flask mass to get the mass of the residue